In this video, the learner will perform a composition of transformations on a figure. It's important that you do these notes on graph paper so that you can practice each one of these transformations as we go. First, we're going to consider glide reflections. This is a composition of a translation, then we follow it with a reflection across a line that's parallel to our translation. So we can see these footprints here. They are following a glide reflection. So starting with this footprint here, we glide along that vector W to get to this footprint. Then we reflect across line L, which is parallel to vector W. And then we end on this yellow footprint. So going from 1 to 3 would be considered a glide reflection. We could take another step and we would glide that foot along and then reflect it across. So we get from 4 to 5. We can kind of see that in motion in this GIF over here. As he picks up the foot, he's gliding that foot, and then when the other foot presses the ground, that's the reflection. Now we're going to practice one. We have triangle JKL, has vertices 6, -1, 10, -2, and 5, -3. We've graphed triangle JKL. Now we're going to graph its image along the translation of 0, 4 and the reflection across the y-axis. So we need to first perform the translation of 0, 4. So that means we're not moving anywhere from our x component, but we are moving +4 along our y component, which means we're moving up 4. So if we translate that figure up 4, we end up with this green triangle J prime, K prime, L prime. And we know we add 4 to our y values for the rule of that translation. So here we perform that rule on those points. Now to get the reflection, we actually use the image from the translation and perform the reflection from it. So I'm using this green triangle now as my pre-image to perform the y-axis reflection. So I'm going to reflect this green triangle across the y-axis to get J double prime, L double prime, K double prime. We know when we reflect across the y-axis that the x value changes signs, so we can see what happens to the points under that glide reflection where we've translated first and then reflected. Now notice we are translating and then reflecting across a line that is parallel to our vector. Our vector was completely vertical and our line of reflection was also completely vertical. Here we have some practice problems. You're going to perform the glide reflection on triangle PQR with vertices 1, 1, 2, 5, and 4, 2. A translation along the vector -3, -3, and a reflection across the line y equals x. For these 4 down here, you're going to tell me whether or not these are glide reflections. So we have a composition of transformations on each one of these, a translation, then a reflection. You need to tell me whether or not we could call these glide reflections and explain your reasoning. Here we're going to reflect the triangle across the line x equals -3, then reflect across the line x equals 4. I want you to stop here and try to go ahead and reflect that triangle across those lines. So first, we're going to reflect across the line x equals -3. That's a completely vertical line. Remember, we reflect across that line by counting to the line and then counting that exact same amount on the other side. Because remember, the pre-image and image points have to be the same distance away from our line of reflection. So we know B is 3 away, so we know B prime is going to be 3 away on the other side. Our original points are A, -9, 2, -6, 3 is B, and -8, 7 is C. When we reflect across that line x equals -3, we get the points 3, 2, 0, 3, and 2, 7. Now I'm going to reflect this red triangle. The image from my first transformation now becomes my pre-image, and I'm going to reflect across the line x equals 4. So when I reflect across that line, I get the points A double prime at 5, 2, B double prime at 8, 3, and C double prime at 6, 7. Now what I want you to consider is there a way that we could have got from A, B, C to A double prime, B double prime, C double prime another way? Is there a different way to express that transformation? I also want you to consider the question, what relationship do the two lines of reflection have? The line x equals -3 and x equals 4. I want you to consider the question, what is the distance between the two lines of reflection? So between the two dotted lines here, and does this value have any significance? So I want you to consider all of these questions when analyzing this composition of transformations. In this next problem, we're going to rotate this quadrilateral ABCD 90 degrees counterclockwise around the origin, then reflect it across the y-axis. I want you to go ahead and try this composition of transformations now. To rotate this figure 90 degrees counterclockwise, remember our rule. To rotate 90 degrees counterclockwise, xy goes -yx. So for each of these points, -1, +6, we'll get -6, -1. -2, +2, we'll get -2, -2. -6, +1, we'll get -1, -6. And -6, +4, we'll get -4, -6. And we have this rotated figure here. Now I'm going to take this image and now make it my pre-image for the reflection. So now I'm going to reflect this blue figure across the y-axis to get A double prime, B double prime, C double prime, D double prime. So now this red figure is my final image, and I want you to consider, could the transformation from ABCD to A double prime, B double prime, C double prime, D double prime be represented another way? So could we get from this black figure to this red figure by another transformation? Okay, next we're going to rotate that same figure 90 degrees clockwise around the origin, then reflect across the y-axis. So we're really considering, does it make a difference which way we rotate first and then reflect across that y-axis? So now we're going to rotate clockwise 90 degrees. And if we remember our rule for 90 degrees clockwise, it's going to be y -x. When we rotate that figure, we're going to get A prime, B prime, C prime, and D prime. Now I'm reflecting this blue figure across the y-axis, and so I'll end on this red figure. Notice it does not look the same from what we just did. So it does matter what direction we start with when we rotate. Now what I want you to consider here is, could the transformation from our original pre-image to our final image be represented another way? Could we get from this black quadrilateral to this red quadrilateral by doing a single transformation? Okay, this is one I want you guys to do on your own. I want you to reflect this figure across the y-axis and then across the x-axis. So A, B, C, and D is going to get reflected across the y-axis and then the x-axis. After you've done that, I want you to go back to the original pre-image, and I want you to rotate the original pre-image 180 degrees clockwise around the origin. So we're going to go back to this black figure and rotate it 180 degrees. And I want you to see if there's a relationship between the composition of transformations that happened first and then the rotation of 180 degrees clockwise. And then I want you to go back and look over all of those examples that we've done and ask yourself, does order matter? Does it make a difference if we reflect first and then translate? Does it make a difference if we rotate and then reflect? So consider those and go back and look at each one of them and see if you would end in the same spot if you reversed the order of the transformations.